Looking from the ground, the sun may look calm and quiet, but in reality it is turbulent and active, sending blasts of energy that shakes our magnetic field. Solar flare, coronal mass ejection, and solar wind constantly travel across the solar system. Hi, we are Team Talestra, a group of 6 members. MD Sohail Parvez, our team leader and content developer, MD Mehdi Hassan Chowdhury, researcher and scriptwriter, Mubashir Shahriar Ornob, media specialist, Nahian Tasmia Bari, video editor, Shahnaz Parvin Sriti, data analyst, and MD Iftikhar Jaman Ratul, UI UX designer. In NASA Space App Challenge 2025, our challenge was to create a digital children's story that explains space weather, changes from the sun that can affect Earth and our technology. We chose this challenge because it allowed us to connect cosmic wonder with storytelling, like introducing children with coronal mass ejection. A CME is a giant blast of plasma and magnetic field from the sun. It travels millions of kilometers through space and can even reach Earth. When particles of CME hit Earth's magnetic shield, colorful sky glow near Earth's pole, the aurora, known as northern light. But these solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communication, and can cause our GPS navigation to fail. To make this complex science interactive and fun to learn, our solution is Space Weather Explorer. It has 5 modules: Blaze Story, Impactful Visualization, 3D Solar System, Track the Storm, and Explore. Now, let's dive deeper into our web application. In Blaze Journey, we learn about CME with the story, The Journey of Blaze. It travels through the space to Earth and beyond. Throughout its journey, Blaze interacts with other characters like satellite, pilot, astronaut, and many more. Also shows us how Blaze create aurora. This story has 13 different chapters. At the bottom of each chapter, there are some questions. By simply answering those simple questions, we can jump into another chapter or just click into the next button. Impact visualization. It gives user a real-time model showing how space weather disrupts satellite operation, GPS navigation, radio communication, power grids, aviation, and aurora visibility based on CME intensity and solar wind speed. When CME intensity is in C class and solar wind is in low speed, all the indication stays normal. When the intensity is in M class and solar wind is in normal speed, all the indication shows minor effect and high possibility of aurora visibility. When it's in X class and solar wind is in high speed, all the indication goes red, means loss of energy. It also shows who get affected by the impact of these. 3D Solar System. It is a simulation system where users launch solar flare and watch CMEs travel from the sun to Earth. They can also adjust the speed of the CME and watch how fast it can travel. Next, Track the Storm. It is a gamified mission center where users can take a mission, earn points, and learn how real scientists protect infrastructure. Explore. This module has 6 tabs: solar flare, CMEs, solar wind, geomagnetical storms, aurora, and take impact. Each tab explains the impact and includes 3D visualization, adjustable intensity slider, where users of every age can understand how connected we are to the sun. So finally, Space Weather Explorer is just not a project, it's a bridge between science and society. It is a teaching tool for teachers, a discovery space for students, and a reminder for public that solar storms are not science fiction. They are part of our everyday reality. In the future, we plan to integrate real NASA and NOAA data to expand mission and launch global multiplayer challenges.